So this recording, I'm going to show on paper the graphical method for resolving vectors. On page 12 of the course notes, there's this example here with 4 vectors acting on a single point. And I wanted to show you how you use the protractor and a scale drawing to find out the resultant vector here. So I'll switch to my camera, which is pointed down on paper just now, so we can see this. What I've done here is I've drawn all 4 of these vectors in, and to show you how they get mapped to our diagram, I've coloured in each one a different colour. This is just so you know when I'm doing my diagram how each vector relates to its position on the diagram, where they're all joined together. So what we're effectively doing is choosing any one of these vectors to start. I'm going to pick the 12 metre per second vector acting up and to the right that I've coloured in blue, and we're going to join them in a line in the directions they're pointing. So for example, if I did the blue one first, which I'm going to do, and then picked the pink vector acting down the way, I would start that line from the end of the blue vector. So let's go through and look at how we would do this. So I'll put this to the side just now, we can get started. So the first thing we want you to do is to agree a scale. Now I'm working on an A4 piece of paper here, so I think it makes sense, given the paper is 30 centimetres across. I'm going to say here, I'm going to draw a line to say that 1 centimetre, I'll move my paper down so you can see it, 1 centimetre is going to be 1 metre per second. So for every metre per second that a vector is in magnitude, I will have a centimetre of length on my line. So that's our scale up here. If we move further down our page, I've got a rough idea of how this is going to look, but remember, that's why I'm using a pencil. If I couldn't fit it on a page, I could always start again. So I'm going to pick here as my starting point, and I want to have an angle acting upwards at 15 degrees from the horizontal. So I'm just going to draw in a little dotted horizontal line here. So this is the horizontal, this is in line with the top and bottom of my paper. And I'm going to use my protractor to measure an angle of 15 degrees here. So what I do is I position the protractor so that its centre point, or I'm pointing to with my pencil here, is on the end of that dotted line. I know it's maybe a wee bit hard to see in the video, but I'm counting round on the inside scale here up to 15 degrees. So there's 0, 10, 15 is a halfway point. So I'm marking a little point here at 15 degrees. And that was marked between this point and this point here. So what I do now is I position my ruler at the start of the point and line it up with the second point, like so. And I want to draw a line that's 12 centimetres long, because if you remember, I'll bring it back into shot just now, our vector acting up and to the right was 12 metres per second. So we'll draw a line 12 centimetres long. I put a little arrowhead on it to show the direction we're going. And I'm also going to colour this in blue, because that is to remind us which vector it was from the original diagram. Like so. Now, the next vector I want to add to our diagram is this vector acting down the way, the pink vector. It's acting down at an angle of 40 degrees, and it's got a magnitude of 15 metres per second. So again, I want to draw a completely horizontal line so I can measure my angle, and I'll just draw it across the top of it. Just a wee dotted line in here, because it's not part of our diagram, but it allows us to see where the horizontal is. We've got our horizontal line in here, and I want to be starting at the point at the end of the vector. I want to line this up, get my middle of my compass, this bit on the end of the vector, and we're acting down and to the right. So I'm counting round from this end, and make sure this is lined up with the straight horizontal line. I'm counting round 40 degrees, and you can see my zeros in the outer scale of my protractor here. So I count round from 0, 10, 20, 40, and make a little mark there. That's an angle of 40 degrees to the horizontal if I draw a line. So I draw this line in here, I'm lining up with the end of my vector, running through the 40 degree point. That angle between the dotted line and my ruler is an angle of 40 degrees thanks to the measurement of the protractor. And this vector was a 15 meter per second vector. So our line has to be 15 centimeters long. So I'll draw all the way down. If it's going off your screen just now, down here. But yeah, you can see just at the bottom right. So that is our vector. And so like with the previous one, I'll put an arrowhead on it to show its direction. And I will highlight this in the colour pink as well, because that was the colour it was in our original diagram. So you'll be able to see how these vectors from the original diagram have been moved across onto this joined up diagram with all the vectors. So if we consider our original diagram again, so that's what I've done. I've effectively taken that pink vector and moved it so its starting point is at the end of the blue vector. We now want to do the same thing with the orange vector. I might have left myself a bit short in space for this, but if not, I'll just cheat and run onto a second sheet of paper. I should have picked either a smaller scale or started elsewhere in my paper if it doesn't fit, but that's okay because I can always rub things out when we're doing in pencil. I'm using colours, so I'll stick with it. So we want an angle of 35 degrees down to the left, and it's going to be a length of 7. We might be okay here. We might be okay. So let's draw in our horizontal line again, so we can measure. Now, just keep this in line with the edge of our paper, the bottom edge here. So I'm just using my ruler to measure that in. Using squared paper or lined paper, well, squared particularly because it's smaller gaps, but using squared or lined paper is really helpful for problems like this. So if you have some or can get access to some, I'd really recommend it. So once again, we put our protractor here, and remember, our angle's going down towards the left, so we have to measure round from this side here. I'm tapping with my pen, so it's the inside scale because that's the scale that starts at 0 here. So I'll measure round, and that is 35 here. Maybe you can see it in the video, but that's in between 30 and 40 at that point, so that's 35. I want to draw a line that's 7 centimeters long. And would you believe it, I have just enough room in my paper to draw this line here, so I'll draw it in. That was a wee bit lucky. And of course, that was the orange line from our diagram, so we'll put that in just now. Now, it might be helpful if I just add on these angles I've measured just to show you where they all were. So this was the 35-degree angle in here. Up here, this was the 40-degree angle we measured, and over here was the 15-degree angle we measured as well. So these are what we took from our original diagram, and of course these are the length as well. I'll put them on too. So that was 12 meters per second on the blue line. It was 15 meters per second on the pink line, and 7 meters per second on the orange line. So now we need to add our final vector to the diagram, and this is our green vector. That was the one acting up and to the right. I'll just bring it up on the screen once more to remind you. So this was our green vector acting up and to the right, 16 meters per second, angle of 20 degrees. So we do the same thing as before. We find our horizontal, which is just in line with our page. I'll draw this dotted line here to help me measure my angle. And we want an angle that's 20 degrees up from this horizontal. So again, I put my protractor on so that center point, the midpoint of the protractor, is at the tail end of the tip of the vector. And I'm going to measure around 20 degrees. So the positive, starting at 0, the scale is here. So this is going to be 20 here. And I'll mark that in my diagram like so. And this line is 16 centimeters long because I've got 1 centimeter for every meter per second. So I'll get my ruler lined up to draw in a line 16 long. And there we go, lined this up, the 16 centimeter mark. It's a bit blurry for you maybe, but I've lined 16 up with the tip of the vector. I'm drawing a line all the way through that point I measured for the angle up here, like so. And I'll move it over so you can see just now. I add a little arrowhead there to my line, and because that was our final vector that I'd coloured green, I'll colour this one in green as well, so you can see how these have joined together. And the details I had from my diagram there, well, this was a 20-degree angle and a 16 meter per second magnitude. So if we compare and contrast for a second, these were our 4 vectors here. And what I've effectively done, I've taken the pink one and shifted it over so it starts from the end of the blue one. And then I've taken the orange one that points down into the left, and I've joined that one at the correct angle to the end of the pink one. And then I've taken our green one acting up into the left here and joined that one to the end of the orange one. And actually what you can do is, no matter which order you add these vectors in, you'll get the same answer to this next part we're going to do. So I just picked the 4 vectors in just the order that we use in the example, but had I picked a different order, what we're about to do would give us the same answer. So having drawn all of our vectors together, to get the overall effect, you'll see there's a gap between the start and the end of our vectors. So what we do now is we draw a line, but this time starting from where we first started our diagram here, we started here, and we'll draw a line connecting that to the end of our 4 vectors, that green point there. So we'll draw this line here. And this is acting the opposite way, because this is our resultant vector. This line that I've just drawn is the combination of what all 4 of those are doing together. So we talk about the resultant, this is the resultant. So I'll colour this yellow, because I'll just make it different. And that's what we're looking for here. Now this is where my drawing skills come to the fore or don't. There's a correct answer on the notes, which will give you a precise answer what this should be. But remember, when you're doing your own work and in any tutorial or assessment, if I can see that yours is approximately correct, it doesn't have to be perfect, as long as you've got pretty close. So the course notes say this is going to be 5.7 centimeters, and I'm measuring here, and I'm getting 5 centimeters for mine. So that's okay. That's okay. I mean, I've obviously not drawn these things in perfectly, but I can say that based on this, mine's 5 meters per second. And I'll measure the angle as well. So I'm measuring the angle down from the horizontal. So I put my protractor in here and measure around. It might be hard to read off, but I'm counting around 0, 10, 20, 30, 40, 50, 60, 66, I make it 66 degrees here. So that is quite close to what the course notes have as an answer, 66 degrees. So the answer you'd give in a question like this is that the resultant is 5 meters per second acting down and to the right, an angle of 66 degrees. So that's one way you could write it. The 66 degrees down and to the right. You want to make sure you're telling me which 66 degrees is not up and to the right or down from the horizontal into the right. That's what you can say as your answer. And that's how we use the graphical method. So you can see I didn't get it quite spot on, but when you do this in the assessment, as long as I can see all your angles are approximately right, you know, your lengths are approximately right, if you don't get the exact answer we've got in the marking scheme, then you're still going to get the marks, because it can be tricky to do these things precisely with pen and paper. But we want you to learn this method, because this is how we need to measure the learning outcome in this unit.